Hey, what's up, Alge2? This should be Thursday if you're staying on track. It could be Friday night or Saturday morning, depending if you're not. Welcome to last section of the week, Introduction to Probability. Just simple probability concepts here. Outcomes in the event over total possible of outcomes. So we spent the last 3 days coming up with strategies how to do this bottom part, the total possible of outcomes, right? Fundamental counting principle, permutations, combinations, trying to think of how we can come up with the total. And then on the top, it's just the event that you want to have happen, okay? So let's just take an example here. I'm looking outside. It's Saturday afternoon. Yes, I'm a loser, 5:21 on a Saturday night. Got nothing to do. Everyone's sleeping, so might as well get some work done, right? Probability that it's going to rain right now is about a 40% chance. So that's almost 50%, so as likely as not. If it was a 100% chance of rain, that means it's certain and it is going to happen. Like it's going to rain. No ifs, ands, buts about it. If there was a 0% chance of rain, that means it's impossible. It will not happen ever for that day, right? So it could be anywhere in between. Now when we talk about probability, 3 ways to write our answers. We can write it as a decimal. So 0.5 or 0.50 as a fraction. 1/2 could be 3/6, stuff like that, or as a percent. Percents are easy to notice because they have the percentage symbol at the end. Okay, so decimals, fractions, percents, either way is good to go. All right, so let's talk about an experiment is a situation with several possible outcomes. So again, we're talking about rolling dice, flipping a coin, picking something out of a hat, stuff like that, marbles out of a bag, things like that. Those are experiments. They have different possible outcomes. And then we've been talking about sample space. It's the set of all possible outcomes. Okay, so if we're looking at the event with a sample space of rolling a cube, well, there's 6 outcomes. The outcomes of the sample space would be a 1, 2, 3, 4, 5, or 6. Okay, pretty simple, pretty basic. All right, so here we go. Probability of box marbles. Pick a marble from the box. There's 1 red, 1 blue, 1 green. What is the probability that and again, this is how we write this, right? This is saying probability. The experiment we're talking about is picking a marble. So what's the probability you pick a marble from the box and it's red? So that's just shorthand notation to say pick a marble from the box. What's the probability that it's red? Okay, well, there's 1 red one out of a total of 3. Second one says probability that it's not green. Well, there are 2 options where they're not green. It's blue and red. So there's 2/3 not green. What is the probability it's purple? You may wait, that's a misprint. No, it's not. How many of those marbles are purple? 0. How many marbles are there? 3. You have a 0% chance of selecting a purple marble. Okay, so going through, being able to read these questions right here is going to be very important. Know what the experiment you're doing, picking a marble in this case from a box. Now what's the probability it's red? Okay, let's go down here. Sample space for tossing 2 dice. It's listed out there for you. But again, let's go to the fundamental counting principle. You're tossing 2 dice. How many outcomes for the first die? 6. Second die, die number 2, 6. 6 times 6 is 36. There are 36 possible outcomes. All right. I just want to, again, take a look here at, we'll just highlight these 2 right here. Okay, a 3 and a 4 and a 3 and a 4. Notice how they are different because the white die is 3, and then the grayish one is 4. this one has the same two numbers, but the white one is 4 and the grayish one is 3. So they count those as two different pairings. So there are 36 total outcomes. Okay? What's the probability now, right, that the sum of the dice is 7? Well, here you go. I'll save you the trouble. How many are there? 7. 6 plus 1, 1 plus 6, 2 plus 5, 5 plus 2, 4 plus 3, 3 plus 4. There are 6 total out of 36, which reduces down to 1/6. Again, if you want to do the percentage and decimals and stuff like that, this is 0.16 repeating or 16.6 repeating percent. Okay? What's the probability sum of the dice is 3? Here are your two, 1 plus 1, or 1 plus 2 and 2 plus 1. So there are 2 options out of 36, which reduces down to 1 over 18. 1 over 18, whoa, got some crazy stuff in my calculator, is 0.055 repeating or 5.5%. Okay? Well, what's the probability, and we're gonna talk about this right here, that the sum is not 3. Okay? We can go through our whole list and add up all the ones that are not 3, right? And then start counting. Oh, there's 1. Oh, shut my pen off. That's why it's not working. 2, 3, 4. Lame, boring, counting all that much. Let's use our brains. We knew that there were 2 of the 36 that had a sum of 3. So we can do 36 minus the 2 that were 3 and get 34 out of 36, right? Divide those each by 2 and you get a 17 out of 18, right? 17 divided by 18 gives you a grand total of 9.9444 repeating or 94.4%, all right? What's the probability sum is less than 10? Okay, so you can count up where's all the numbers that are less than 10. It's going to be all these ones, right? All those ones. I'm not going to count all of them. I'm going to count the ones that are 10 or higher. Here's 10, here's 11, here's 12. So there's 1, 2, 3, 4, 5, 6 options that have a sum that are 10 or higher, so everything else is 10 or lower. So if 6 out of 36 are 10 or higher, that means 30 out of 36 are going to be lower. 30 divided by 36 gives us a grand total of 0.83 repeating or 83.3%. All right, what's the probability the sum is 1? Can happen. You were rolling 2 dice. You got a 0 out of 36% chance, which for some of you, that's the chance you're going to have getting a date for prom next year. Boom, ba-doom, tsh, just kidding. All right, so probability sum is less than 13. No, highest sum is 12, so all of those options are going to be less than 13. So you have a 36 out of 36% chance. Or that answer, when you divide it out, I'm going to again show you that it's 1, right? So anything in between 0, oh, why does my pen keep shutting off? Whatever. Between 0 and 1, or 0% to 100%, right? So it's any decimal in between 0 and 1, any percentage from 0 to 100%. Okay, so that's us talking with dice. All right, let's go to a little fundamental counting principle action again. Family with 3 kids. What's the probability that the family had 2 girls and 1 boy? Probability they're all girls. Probability none of them are girls. Okay, well, first off, we have to think about what is our sample space. It's not as laid out in front of us like this last one where we were rolling 2 dice. or a deck of 52 cards, or you're flipping a coin, it's heads and tails, we know the outcomes. So we have to go through and figure out the sample space here. Well, we can do the tree diagram option, or we can just say, hey, kid 1, 2 possibilities, boy or girl. Kid number 2, 2 possibilities, boy or girl. Kid number 3, 2 possibilities, boy or girl. 2 times 2 times 2 is 8. So there are a total of 8 outcomes. Well, what are those 8 outcomes? Let's list them out down here. So boy, 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 girl. And then we got boy, girl, boy, and boy, girl, girl. Now what happens if the first child was a girl? It could be girl, 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 or girl, girl, boy. Could be girl, boy, girl, or girl, boy, then a boy. So those are our 8. Okay, those are going to help us out. What are the probability that it's 2 girls and 1 boy? Well, here's one that has 2 girls and 1 boy. Here's one that has 2 girls and 1 boy. Here is a third one that has 2 girls and 1 boy. So that's going to be 3 out of 8. 0.375, which is 37.5%. All right, what's the probability that they're all girls? Well, there is one right here where they're all girls. That's a 1 out of 8 chance. 1 out of 8, 0.125, or a 12.5% chance. Okay, what's the probability that there are no girls, which is also saying that they're all boys? Again, that's going to be, here's the one where it's only all girls, so 1 out of 8 equals 0.125 or 12.5%. Okay, so this next option here, this next thing is the complement, where you take 1 and subtract out the probability of the event. All right, we did that concept up here when we talked about the numbers that the sum of 3 versus the sum not 3. We didn't do the probability. We didn't take 5.5% and subtract that from 100%. We didn't do that. What we did is we went to our total sample space and subtracted out there. But it's that same principle of, hey, what's probability right now? It's 40% chance rain. What's the probability of no rain? Well, we know that 40% is rain, so 100% minus that 40% gives us that 60%. So same concept that we used up there, but we hadn't found the probability when it was the sum of 3. We were just finding the possible outcomes and then subtracting that from the whole. This is using the idea, same idea of complement, but subtracting it when you actually found out the probabilities. So take a look at your lesson. Again, no quiz this week, so just 4 sections worth of work. Practice them up. You are going to have a quiz next Thursday. Okay? Next Thursday. Happy Memorial Day. The light is at the end of the tunnel. 1 more week of learning after this. McMorrow out.